Right. I mean, phone battery is low. So it's on charge now. Let me just show you again. Oh, there you go. See, it just stopped. And it's actually switched it off, and you can see the voltage has dropped, so obviously I stopped providing power. Yeah. Now we'll do the same, because it's actually connected now, and you can see this is on 3.97, so if I put this one on, you'll see it'll rise. Now, this one hasn't got any software in there to sense when it hits the voltage, so obviously I need to replicate that. Yeah, but you can see how it's rising. This one's already on 4 volts. Yeah. The middle one, obviously. Not charged. Yeah. Now, as I say, there you go, it's hit 4 volts, right? So we're okay. And if I turn it off now, which is what would normally happen, you'll see it'll drop again. There we go. So it's working now. I'm tethered to a charger right now because of the fact that it's a problem, but you can see how I've got the 3 circuits and they're working. So what I need to do now is essentially adapt the software so that it will do the cell balancing itself. And the way I want to do it is basically you really need to do it to the highest voltage, because obviously you have to bring them all up. Now, as you're charging, if you don't have a charger attached, then the highest voltage will actually reduce because you're pulling charge from all of the cells to put into one. But the cell balancing circuit does look like it actually works. I mean, look at them. 392, 4.0, 397. Yeah? Yeah. So it's working fine. And if I actually increase the voltage now, yeah. The problem is of course, it settles back down again. That's the problem right now. So what I really want to do is get it up to 4.0. If I can do it, let me see. So if I put it on, but what I'll do is I'll just temporarily put it up to 4.1, which means it'll then settle higher. You see, and it'll turn off when it's on 4.1 if it gets there, because I don't know if the charging circuit will actually reach 4.1. Yeah. Yeah, see? So it is working, right? And I've had another thought about this. What I might do instead, I need to get that LM317 circuit working. But the thing is I'm needing a load of relays if I'm going to be doing stuff like that. You know, basically I need a load of digital outputs, and this one doesn't have that many, so I can switch to the points in the circuit that it's trying to measure. And certainly if I've got 13 cells in there, that's going to be immense. I'm probably going to need 26 relays so that I can measure the points in the parts of the circuit. But I think perhaps the better way to go, certainly the less complicated way to go, is just to get more accurate components. There's also stuff online about how to make the ADC input more accurate, like using in actual fact using an LM317 to as a supply for the ADC, and that will work as well. So that's currently where I'm at right now. Let's just a quick zoom so you can see. There we go. It's looking quite good. You know, one relay per thing, and what I'll do in the actual circuit is, instead of using these, which are just standard relays, you energize the coil to make it switch, you'd use bistable relays. Yeah, and a circuit which will switch it bistable, so it locks on, so you're not constantly putting power on. Although the power it takes is actually quite small, you know, to energize the relay itself, it's still power, and you obviously wouldn't want to draw power if you are actually trying to charge it. Yeah. So but this is really just sort of like, you know, just sort of theory, essentially, to make it sort of work electrically. And we're not even talking about the amount of power that the Arduino itself takes, which obviously is going to be power. Yeah. And at the moment it's not. Yeah. And that I mean, ultimately in a car that will be drawn from the battery, the Arduino's power itself. So yeah, you know, anyway, there we go. Just a quick update essentially.